Dear friends, welcome to this electrical engineering knowledge sharing channel AMP Power System. We are discussing about the UPS system. Under this workshop 9, we have already discussed 3 videos: basics of the UPS, then undistributed UPS system, and the distributed UPS system. That is the configurations we have completed. Today we are going to discuss the fourth part, that is the sizing estimation of UPS system. When we are going to discuss about the sizing estimation or sizing calculation of UPS systems, it includes not only the UPS but its associated other parts or subsystem. As we have already seen in the previous 3 videos, when we talk about the UPS system, the UPS system has different subsystems. If we look into the various subsystems, it mainly include the main part of the system is a UPS itself. That is a UPS itself, that is consisting of rectifier, inverter, and the static switch. That is the 3 part of this UPS: rectifier or converter plus rectifier, converter plus inverter plus a static switch. These are the 3 major parts of the UPS. Then we have the second subsystem is the battery. Battery is the second subsystem. That is the second system. Third system is the various cables. That is the input cable of the UPS, output cable of the UPS, a static switch bypass cable of the UPS, and the maintenance bypass cable of the UPS. That is various cables. And the third part of this system is the breaker, input output breakers, maintenance bypass breaker or circuit breaker or switch, and this protection setting. That is the various breakers. That is the input output switch, you can say another way, input output switching device plus their protection settings. These only mainly include when we are going to discuss about the UPS system sizing. Okay, that is one of the part. But when we are going to discuss this various subsystem sizing estimation, we have to follow some steps. Now, the steps which we need to follow, that is first step to decide the UPS. Now, what are the or how, in what parameter this UPS system sizing is decided. Now, first we go to the UPS itself sizing. When you go to the UPS itself sizing, UPS may be considered as a generating system because it is giving a uninterrupted, noise-free power supply to a loads. So when some equipment supplying power to the load, that supplying equipment we call as a generator normally. So in the case of normal electrical power system, we have electrical generator, that is we have a mechanical engine, that may be your turbine, gas turbine, steam turbine, hydraulic turbine, or any form of turbine which is driving an alternator, and the alternator is producing electrical power to the various loads. Now, if you look into the alternator sizing, I have a video on that, you can look into. Always these power devices, these power generating devices sizing, we calculate in terms of kVA. Okay. Now, that's why the UPS system, when going to the UPS system sizing, first part of the UPS itself, that is the rectifier, converter, and static switch, that equipment sizing also we nomenclated in terms of kVA and the voltage. So when we are going to UPS system, first system sizing calculation, we will be deciding the sizing calculation in terms of kVA. Okay, that is the first part. So sizing of this UPS itself is decided in terms of, normally in terms of kVA. Okay, we know the kVA, that is equal to kV or voltage into ampere. So we need to know either the load, this when we deciding the KVA, we need to know the voltage and the current. These are the two parameters to decide the KVA of the equipments. So that is the first part. Second part, when we are going to decide the UPS sizing, we need to know the loads which would be catered by this UPS. That load, we need to analyze the load in thoroughly. We are discussing about the UPS system for the industrial plant, not for the small domestic application. This UPS sizing calculation we are doing for the industrial plant where there is various critical loads. This any plant, when we divide the load, we can divide the load in three major categories. One is a normal load, which is supplying by the gas turbine or steam turbine normally. So in case of shutdown, when the steam turbine got shut down, then we have an emergency generator in the plant. That emergency generator gets up and it gives the power to the emergency loads. And during this interval, that is the emergency generator starting and the main power fail, between that interval we have some time. So that time some of the loads needs power at that time. So that type of loads, and sometime if this emergency generator fail to start, at that time we need some of the loads need to be supplied continuously. Those type of loads we consider as the critical loads, and those critical loads to be supplied by the UPS. So when we are deciding the UPS sizing, once we know the sizing is to be decided in terms of KVA, the second part of this discussion or this estimation is what are the loads I need to cater for by the UPS. So to do that, we have to analyze the load. That means we have to identify all the loads of the plant which are being treated or to be considered as a critical loads. So as per my experience, whatever the work we have done for the various plants, the critical load, maybe it will be different type. Like if you say fire and gas system of any industrial plant, they have a fire and gas system. It is a safety ecosystem. The safety system needs UPS power. So that safety system is one of the critical load we can consider. We call it fire and gas, in short form we call F and G system. That is one of the critical load. Then we have any industrial plant, process plant or power plant, there is a huge distributed control system, which is nowadays doing all the control, monitoring, data gathering, data communication, all this thing is doing by this DCS system or distributed control system. That DCS system also has a critical system for any industrial plant, distributed control system. Third load is that, this any industrial plant, there is a telecommunication system. There may be normal telephone system, there is a communication system, means transmitting telemetering system, transmitting data from one place to other place. So interconnection or intercommunication amongst the various sub-plant of the main plant. So that telecommunication system also needs the UPS power. That means telecom, or we can say communication system. That is also as a critical load. Okay. Then we have the entire plant. There are some light which need to be lightened under this shutdown condition or emergency generator running, and this between this interval, or in case of emergency generator fail, those type of loads, those type of lights need to be lightened by the UPS system. So there is a lighting system. That is also a critical load for the UPS system, to be considered for UPS system, lighting system. Then when you are shutting down any power plant or any generators, there is some loads which need to be run continuously. That may be some motors or some small pumps. There are so many things are there which needs to be continuously running during shutdown time when there is no power available. So that shutdown system or this generating station shutdown system also needs some UPS power. That is called power shutdown system, you can say. Power shutdown system. That is also need power. Then when you want to start up any plant, there also needs some critical power, because that time maybe no power is available. So a startup also needs some UPS power for starting up. A starting up power, that is also needs some power. Then if you look into this, in a circulation, air circulation system, there is some circulation system which needs critical power. Like a battery room fan is to be run continuously. Even the power supply fail, battery room fan, exhaust fan to be run. So there, like this, then suppose there is a pressurized room where some equipment is there, where the room pressure is to be maintained above the atmospheric pressure. So room continually pressurized by some pressurization fan, that fan to be run continuously. So that type of power supply also required on the critical load. So pressurization system, or you can say air circulation, air ventilation system also needs sometime UPS loads. So if you look into the plant, there's so many type of critical loads are there. All these loads one by one we have to analyze with the client. With this, if we are the consultant, we need to discuss among the party, among the client, other vendors, their equipment, whether they need any critical power or not. Accordingly, we have to identify all the critical loads. Once the critical loads are identified, then we have to make a small table. That is, this part we call it a load analysis. So if you look into this determination of the UPS per kVA, so first part we discuss, it is to be kVA. Second part is a load configuration, that is a load analysis. This is part we call is a load analysis. The load analysis is to be done. Third part we call is a what is the configuration system we need to look into, configuration of the system. And fourth part, when we are doing the load analysis, it is not only do the load analysis as we discussed just before. In addition to this, we need to identify these loads, whether it is a single phase load or three phase load. Based on that, UPS sizing is dependent. Whether the load is single phase load or three phase load, that also we have to identify during the load analysis. Then once the load analysis is done, then we have to look into the configuration. Based on the configuration, UPS sizing may change. So these are the three major parts we need to follow when we deciding the UPS. Now we are discussing about the load analysis. So we have already discussed how to identify the critical loads. Once the critical load is identified, or the description of the critical load is identified, the next part is we have to look into the critical load value. What parameter of the critical load we need to look? That is, we will be discussing. First part of this load analysis is, once the load is identified, now we look into the parameters. Which parameter we need to record for this critical loads? First is what is the voltage, rated voltage of the critical load? That is the first part we need to look into. Once we find the voltage, rated voltage of the critical load, then we have to look into what is the current of the critical load, rated current of the critical load. That also we have to note down. Then third part, what is the power factor of this critical load? That is also we need to look into. And fourth part, we have to look into this load is a single phase load or three phase load. That is also we need to look. Once the load is identified, single phase or three phase, then we have to look into whether this particular load is continuously from the start up to the end, always take the constant current, or it take the variable current, or it has some inrush current. So that also we need to identify. Sometimes some of the loads is not giving its current in voltage and current value. It may give in direct VA, volt ampere. Then our job will be very simple. Then we will record that volt ampere and the voltage. If the current is not directly given, sometimes the sum of the loads, they don't give the current value, they give a voltage and VA value, volt ampere value or kVA value. Then that will capture. From there we can calculate the current. Suppose any of the load they have given the kVA or VA value, volt ampere, and the voltage value. So we know current I equal to VA by voltage. Voltage, from there I can get the current value. So if the VA and voltage is given, we can calculate the VA or kVA, and if we get the voltage and current directly, then we'll multiply the voltage and current to get the VA, and then we have to add the power factor if we want to know the kilowatt. So these are the basic things we need to identify for all the critical loads. So load analysis part, so we can make a small table for analysis of the load, how the load to be analyzed. I am giving a short form over here. First, we give one column serial number, how many loads we have, serial number. Second part, we will be discussing about the description of the load. What are the load description? Okay, description of the load we will put. Then we need the voltage, rated voltage of the load. Okay, rated voltage we will put over here. Then we will put the rated current of the load. Once we decide this is the rated voltage, this is the rated current, then we can calculate the VA of the load, right? VA of the load or KVA, VA or KVA, whatever is there, that is we can calculate. Then we need to know the power factor of the load, we will calculate over here. Then we need to know the phase of the load, it is a single phase or three phase load, that is we need to know. Then we have to know the characteristics of the current. Characteristics of the current is there is an inrush current or constant current, or there is a variation of the current, and what time is this current, that is also we need to know. And then last part, we need to know the duration of this critical load running, how many hours or how many minutes or how many seconds this critical load to be run, that time is also required. This time is required not for the UPS sizing, but this time will be required for the battery sizing. So that time, running time of the load from the UPS system is also required to be decided. Okay, so these are the basic parameters when we are going to analyze the load for each and every load. Once we capture one load, immediately we have to note down all these points. So sometimes, though electrical engineers are doing this calculation, some of the loads not belonging to the electrical engineer, some of the loads belonging to the instrument engineers, like fire and gas system load, DCS load. So you have to communicate with your counterpart of the instrument engineer who is working with you for this estimation. From him you have to get all the parameters and then you have to calculate it. So let's consider one. Suppose I have a first fire and gas system. Fire and gas system. Suppose the rated voltage I am telling it is a 240 volt or 240 volt. It is the rated voltage. And suppose the rated current is a 10 ampere. If that is the value, then how much VA will be there? 240 means it is a 2.4 kVA, right? 2.4 kVA. 240 into 10 multiply is a 2400 VA, that is equal to 2.4 kVA, right? This is the kVA. I am calculating all these terms in kVA. So this is a 2.4 kVA. Now the power factor of the load, suppose it is a 0.9. Suppose this fire and gas system, all the loads are single phase load. So it is a single phase. Then the characteristic of the load, this load is a constant current. It draw always constant current. So it is a constant value. Okay. And we may consider this fire and gas system always started from the UPS system. So you can say it is a continuous, the time is a continuous. And 24 hours this power supply will be going from the UPS system. We can consider it in that way. So this is one of the load. Second load, suppose DCS system load. So here also suppose you have to calculate the rated voltage. Suppose the rated voltage is same 240 volt. And the load, how much current? The current maybe it is a 15 ampere or 20 ampere current is drawing. If it draw 20 ampere current, then it will be 4.8 kVA. Suppose this power factor is 0.95. The load is a single phase, we consider. The current is a continuous and the characteristic current is constant. That is also we can calculate this way. Now the third load, suppose there is a air circulation system. There is some critical load, there are some fans to be run. Suppose those fans are three phase fans. So suppose, let us consider now it is a single phase. Then this decision will be easy. Now it is a third part is a air circulation system. There is some critical load. Suppose those fans are running by 240 volt motor. Suppose the motor normal current maybe it is a 5 ampere. Okay. But now the problem is this motor, and suppose this how much voltage it will be? It will be 1.2 kVA, right? That is the kVA of this motor. And then power factor maybe it is a 0.85, 0.85. It is a single phase motor, okay? And it is a characteristic this current. This current is not constant, because when the motor will start off, it is a motor. Air circulation system running a fan means it is a motor. The current is not constant. There is inrush current during a starting. So characteristic of the current is not constant. There is a inrush current. Inrush current is there, right? And the time of the induced current, how much? This induced current, this fan will be running continuously, but induced current duration is during a start of the time. So we have to note down the time, these characteristics. Current is constant except starting time. A starting time induced current I may consider 5 times, means it is 25 ampere. Or it is a small motor, it may be 6 times, we can consider 30 ampere is the induced current. That is we have to consider. So we can write here rated current slash induced current here. Induced current is 30 ampere. Here induced current is 0, there is no induced current here. But in this load, for this air circulation system, I have the induced current. Rated current is 5 ampere, but induced current is 30 ampere. That may be required for 5 seconds. I can consider in that way. This time, the time is 5 ampere current continuous, but 3 seconds, 5 seconds during a starting of this fan, it will draw 30 ampere current. Okay, this current we are talking all are RMS current. Okay, RMS current. Now, fourth load we may consider, that is your suppose telecommunication system or communication system. So suppose this load is 240 volt. The current is a, suppose the current is a 2 ampere or 5 ampere. At same, it has no induced current, and then 5 ampere means it is 1.2 kVA. And power factor is suppose 0.9. It is a single phase load. It is a nature is a constant current, continuous. So this way, each and every load we have to tabulate. Once we tabulate all the loads, then what I have to do? I have to see this voltage is same 240 volt, but the rated current I have seen, and the voltage is this. So I have the VA. So we will calculate the total VA over here. Okay, how much kVA? Continuous kVA, how much? I have a continuous kVA 2.4, 1.2, 1.2.4, 4.8, 4.8 into 4.8 means 9.6 kVA. If I consider these are the 4 critical loads, then I have a total kVA is a 9.6, voltage is 240 volt, and summation of the current how much? 10, 20, 40 ampere, right? 5, 5, 10, 10, 20, 20, 40 ampere is a starting constant current. Induced current how much? This 30 ampere, and during induced time all these are running. So this induced current will be 35 means 65 ampere. So during starting off, the total current will be normal, this current will go, and for this load it will not take 5 ampere, it will take 30 ampere. So 30 ampere plus 5, 35, 45, 65 ampere current it will draw during this 5 second time. That also the UPS which will be catering the load, that should have that capacity. So that is also to be noted over here. So when we are considering 65 ampere current, then this kVA will be different, that we will calculate separately. So this means this is a 1.2 kVA normal, but during induced time it is taking 6 times of that, means it is a 7.2 kVA it is drawing for 5 seconds. We have to note down this point over here. VA or kVA constant plus induced. Induced also we have to note down over here. That is with slash. Okay. So during induced time, this particular lead only taking 7.2 kVA, means it is a 6 kVA more. That means it will be during induced time, it will be taking 15.6 kVA. That also we have to note down. In this way, each and every load, all these parameters to be decided. Accordingly, we have to calculate the continuous current, induced current, continuous kVA, induced kVA. Then we will go the sizing of this. How we will do this? Based on the phase, first we have to look into it. Now we are deciding the UPS. How will UPS size will decide? Once the load analysis is over, then we have to look into how the phases of the load. If the load is all a single phase load, that means UPS output is required single phase. But suppose this air circulation fan is a 3-phase fan. We have seen the configuration of the UPS, how it is. It is our rectifier. This is AC supply. This is a DC. There is a battery connected over here. And then I have an inverter. Is supply is DC, output is AC. This AC is going to there is output breaker. It is going to the load, right? This is our configuration. Now, if this load is 3-phase, that means I need a 3-phase bus over here. That means this UPS need to give 3-phase output, right? But if all the loads are single phase, then I need the UPS output is single phase. Inputs could be anything. Okay. So that's why to decide the UPS output voltage, it is very, very important to know the load phases. It is a single phase load or three phase load. If the load are all single phase, the output of the UPS will be obviously single phase. But the question is, what is the total kVA requirement? If normally single phase UPS means, what does it mean? Now the UPS in terms of phase, UPS can be designated three different types. UPS in terms of phase, we can decide the UPS three different types. This input voltage based on the input and output voltage. Okay, this if the input voltage is, suppose input voltage is single phase, output voltage is single phase. In that case, this UPS system we term as a 1/1 system. Meaning input single phase, output single phase. But if the input is three phase and output is single phase, we say 3/1 system. Means input is three phase, output is single phase. But if the input is three phase, output is three phase, then we say 3/3 system. So these are the three terminology we use when we size the UPS. So 1/1 system or 3/1 system or 3/3 system. 1/1 system means input is single phase, output is single phase. 3/1 means input is three phase, output is single phase. Here input is three phase, output is three phase. So this will decide the UPS configuration. Now whether input I can get from the system single phase or three phase. Now we consider output. If the load is three phase, I have no other option without considering three phase output. What about the KVA? What about the KVA is there? It is indifferent. If the output voltage for any load is a three phase, suppose this air circulation system is a three phase. In that case, though other loads are single phase, but I don't have any other option without going to three phase UPS. In that case, I have to go three phase UPS system. That means output will be three phase. In that case, what I'll go 3/3 system. Okay. But if all the outputs are single phase, in that case, obviously, output if is a single phase, then it will be either 3/1 system or 1/1 system. Now, which will I will follow? That depend on the KVA. Normal practice, if the UPS is within 5 to 7 kVA capacity, in that case, we can control within this 1/1 system in single phase input, single phase output. However, if the system capacity is more than 5 to 7 kVA, suppose 10 kVA or 15 kVA, in that case, we go by 3/3 system. Input is three phase, output is three phase. Then, if the KVA is more than 7 kVA, normal practice, 5 to 7 kVA, up to 5 to 7 kVA, all the single phase load, if all the loads are single phase, we go by the 1/1 system. But if though loads are single phase, but the KVA capacity is more than suppose 7 kVA, in that case, we do not go by the single phase UPS. We go by the output three phase UPS, and the input we take also three phase. In that case, it will be 3/3 system. And third option, if any of the load is three phase, then I don't have any other option without going output three phase. So input obviously will be three phase. So 3/3 system will be in two cases. One case is if the UPS load, any of the load is three phase, we have to go 3/3 system. And if the total KVA requirement for the UPS is more than 7 kVA, then it will go by 3/3 system. Otherwise, we can go 3/1 or 3/3 system. These are the normal practice for the UPS system deciding. Now, once the KVA is once the KVA is decided, continuous KVA decided, then we can calculate the UPS size. Suppose let us consider first all the current is a constant current. Meaning there is no inrush or there is no dynamic current. All the current are steady state RMS value. In that case, based on the KVA 9. Suppose this KVA UPS based on the full load, the steady state current is 9.6 kVA. So based on the 9.6 kVA, what we will do now, we have to decide the actual how much kVA for the UPS. First, we have to put some margin because this is we are deciding based on the load, but tomorrow some additional load may be added. So always for the generating system, when you are sizing the generating system, it is always better to put a safety margin. For the generating system, we put safety margin 25%. Normally, 25% safety margin, so that in future if some additional load comes in, we can add to the UPS system without changing the UPS. That is first part. Second part, this UPS system is a solid state devices, right? This UPS system always is 99% time it was installed inside the air conditioned room where the temperature is maintained suppose 24 degrees centigrade, right? So that is the ambient temperature for the UPS system. Suppose this is a room where the UPS system is installed, yeah, and the room temperature is maintained by air conditioning system whose temperature is constantly maintained 24 degrees centigrade. So to the UPS system, this is the ambient temperature. Now suddenly suppose main power supply fail and the UPS system room temperature is not maintained 24 degree, then room temperature will continually going up, because at that time the moment main power supply fail, UPS is also running, and you solid state devices produces lot of power, a lot of heat. So it is, as it is producing lot of heat, so it will give a lot of room temperature will be going up. So now every electrical equipment, it has a rated capacity. Okay, suppose this is the rated capacity. Normally rated capacity of the system is up to 75 degrees centigrade, it will giving the rated capacity. Suppose now the moment the temperature goes above 75 degrees centigrade, immediately the rated capacity will go down like a 45 degree angle. Okay, suppose this is the 100% capacity a equipment is delivering up to temperature. Suppose this is the rated operating temperature up to this room ambient, this is the ambient temperature. Okay, this is the ambient temperature. Up to this ambient temperature, it will give 100% power. The moment the ambient temperature goes above this value, suppose this is the rated ambient temperature, the moment the rated ambient temperature goes above, then immediately this rated capacity of the equipment, this is 100% capacity at this point, it will gradually fall and it will drop down to 0. So if this is the rated condition, this amount will be nearly same value. It has seen the gradient of this curve is 45 degree, tan theta equal to 1, which linearly drops. So every degree centigrade drop, maybe capacity is reducing 1.5 to 2%. So if there is a temperature when this main power supply fail, room temperature, if this rating, suppose this 9.6 kVA required at 24 degrees centigrade. Now if the temperature goes up, then automatically the capacity will drop down. So that temperature derating factor we also need to consider when we are deciding the UPS sizing. This part we need to discuss with the vendor who is manufacturing the UPS. He will give you the data, his UPS size at what temperature, what ambient temperature it can deliver its rated power, up to what temperature. If our ambient temperature above the rated temperature of that operating temperature of the UPS, then we have to apply the temperature derating factor. So temperature derating factor we have to apply, that is one of the factor, temperature derating factor. And number 2, we have to put 25% safety margin. These are the two things we need to consider when we are sizing the UPS under steady state current condition. So suppose this kVA is a 9.6 kV is the 20 at operating temperature of suppose 30 degree or 40 degrees, 40 degrees centigrade. So if the temperature goes above 40 degrees centigrade, so first with the 9.6 kVA, 9.6 kVA is a load kVA, so we can consider suppose 10 kVA round figure. So 10 kVA into temperature derating factor TD, that will multiply TD, and then we put 1.25 safety margin, that will give me the capacity of the UPS required in VA. This is the VA. Suppose TD equal to 1.1, you consider. So it is coming 10 into 1.1 into 1.25, it will coming about 10, 12, about 14 kVA. So in the round figure, what we'll do, we'll put 15 kVA UPS. So we'll tell we need the UPS is a 15 kVA. That is the main part of this UPS size. 15 kVA UPS is required. This way we'll calculate and give the round figure. That is the first part of the UPS system for the steady state load. Now you consider the load is not steady state, it is tangent load. Now if the tangent load, then it depends on the sequence of operation. If this tangent load or this inrush load is required only one time during a startup, in that case the additional inrush current or inrush kVA required during a startup, I need not to incorporate in the UPS system. Why? Because at that time what I can do, when if this inrush current, if we look into the critical load and we look and we found that this critical load will be running during a startup only, in only one time, not continuous. This is not sequentially coming and going, it is only one time it is operating. In that case, what I'll do, we have seen the UPS configuration. This is our UPS configuration, right? And we have a bypass and it is going over here. This is road, and then we have a maintenance bypass, right? This is maintenance bypass. It is connected to the source. So if we see the critical load is coming during a startup only, so at that time, during a startup, I will switch on the maintenance bypass and I will start the motor, or I will start all the in-rush devices, because at that time the power is going to the maintenance bypass means through this cable, and this switch means MCB or breakers, and this is connected to the main source, means our main power supply. So that is we can consider that is infinite capacity, and we have sized this cable to be sized based on the in-rush current, all these things. Then I can switch on the maintenance bypass and it will run all these loads fast. On these in-rush devices, suppose the circulation pump or circulation fan, then generator, shutdown devices, or any other startup devices required, those devices I will run through this. And once it is start off, then I will switch on the UPS and transfer from the maintenance bypass to UPS. In that case, UPS will not be subjected to the in-rush current. So that way, the UPS system sizing will remain 15 kVA. But if this air circulation fan not only during a starting time, intermittently also it is coming. Suppose every 1 hour or 2 hours it is switching off like that. In that case, every time in-rush current is coming. In that case, I don't know when the in-rush current will come. In that case, I cannot do this thing. In that case, the additional capacity required is to be put inside the UPS system. So how I'll do that? In that case, during current calculation, I have a kV, I have a voltage. How I have calculated voltage? Voltage is equal to voltage into current, right? All the current, we have sum all the current, right? This is the summation of all the steady state current. So here what I'll do, I will calculate all the steady state current except the in-rush part, okay? Except the in-rush part. Then what I'll do, I will sum this total sum. I'll do ISS plus summation of I dynamic current, dynamic state, okay? Dynamic state current. Also, suppose these are the in-rush current, I will add up over here. So this current plus this current, this will give the total current. From this to total current into multiplied by voltage, I will get the total VA, and that VA to be included in the UPS system. Now, if this dynamic load, suppose the dynamic load is only for 1 second. In that case, I may not consider this dynamic load because UPS has inbuilt overload capacity. Normally, any UPS, it can give 200% overload capacity for 1 second. 200 UPS overload capacity or short circuit capacity is not like generator. So it is a maybe one that we need to discuss with the vendor and reconfirm from the vendor his UPS system or UPS how much short circuit current capacity or overload capacity. If we say my system can take 200% overload capacity, 200% overload capacity for 1 second or 2 seconds, and if this dynamic load is less than 2 seconds, then I will calculate. Suppose I have a 15 kV, I have taken a 15 kV UPS system. So 15 kV UPS under short circuit condition, it can cut a 30 kVA for 2 seconds. So if I see that my total load requirement is less than 2 seconds within the 30 kVA, then I need not to consider this dynamic load separately. But if the time of operation of the dynamic load is more than short circuit capacity and UPS cannot cater for that, then I have to include that additional or differential power required for the dynamic or transient current. So this way we have to calculate the dynamic load UPS sizing. So these are the mainly the UPS sizing part. Once the UPS size is decided, suppose I need a 15 kVA UPS now or 15 kVA total load. Now I need to go the configuration. Now this 15 kVA, whether I will cater by one UPS or multiple UPS. We have seen the various configuration. That is, N is the number of system, number of module we require to cater for UPS. If N is the number of module, now if N equal to 1, then the UPS will be 15 kVA for 9.6 kVA continuous load, right? Now if this N I decide 2, then each UPS will be 7. If we go for parallel system, then each UPS will be 7.5 kVA. That means I have a 2 UPS like this. It has a bypass connected over here, and then there is another UPS over here, similarly connected on the same bus, and then there is a, suppose this is n plus 1 system and n equal to 2, so these are the two required for the continuous. Then I have a one standby UPS over here, a standby. That is the third UPS is a standby. So these will be the configuration, but if n equal to 1, then I have only one system and then I can take one standby. That is why. So configuration also important over here to decide the UPS sizing. For 15 kVA total UPS requirement, it could be 1 plus 1, it could be 2 plus 1, it could be 3 plus 1 or 3 plus 2, whatever. If we go for 3, then it will be 3 5 kVA UPS module, and then we will go for 1 or 2 standby. That depends on our configuration. So configuration is also important part of the UPS sizing. So this way we will decide the UPS total capacity for the any plant. Okay, that is first part of this. Now the next video we will discuss about the battery sizing, how we do the battery sizing. Once the battery sizing is decided, then we go for the cable sizing. But cable sizing, I will recommend all of you to refer my video on the cable sizing. I have already made one video how to size a cable for the any load or any equipment. You can refer the cable sizing of that. In that case, we can avoid that video. Then the battery sizing calculation will be the next video, which will give you the picture of how to decide the UPS sizing. So I am closing this video at this moment with this. So please go through this UPS sizing. If you have any queries, please let me know so that I can address it to you. And that's all at this moment. And if it helped to you, that is great for me. And thank you very much indeed. Thank you.